All right, so we're going to look at population intervals in our first example. An example of an early application of statistics was in the year 1817. A study of chest circumference among a group of Scottish men exhibited a normal distribution. So I don't know why they were measuring the circumference of Scottish men's chests back in 1817, but they collected data and they found that it was a normal distribution. So keyword right there. Their chest circumferences ranged from 33 to 48 inches, with a mean chest measurement of 40 inches and a standard deviation of 2 inches. Use the empirical rule to help you understand the distribution of chest circumferences in the study. Okay, so they told us the mean chest circumference was 40 inches and the standard deviation was 2 inches. That's enough information for us to draw a normal distribution for this data set. So that's what you're going to do. I think that having the visual helps out. You'll see why. So here's my number line. Here's my bell curve. I am going to draw a line straight down the middle, and that's where my mean is going to go. So the mean is 40 inches. Sometimes I'll even put a box around that because I'm about to get more numbers on this number line, and I just know that's the middle, that's the mean. Everything is in relation to the mean. All right, so our standard deviation is 2 inches. So what we're going to do is we're going to count by twos. We're going to divide up our normal curve. I'm going to count by 2 inches, and this is going to be 42. I'm going to divide it up again. Here's 44, and we only have to go 3 numbers above and below the mean. These are our standard deviations. Divide it up again, and here we have 46. Now let's do the same thing below the mean. So on the left side, try to be symmetrical and trying to make it look nice, but it is what it is. So I'm counting by twos, 38, and I'm going to go down by 2 to get to 36, go down by 2 again to get to 34. So there is our normal distribution. We've got the mean in the center, and we are counting by standard deviations. All right, what range of chest measurements contains the 68% which fall closest to the mean? So we want the middle 68%, and we just learned in the learning and target and vocab video that the middle 68% is going to fall within 1 standard deviation of the mean. So let's just make a note. We know that 68%, that's one of our special percents. So we got 68, 95, 99.7. Those are the 3 we're going to work with. 68% of data fall within 1 standard deviation. Well, that looks dumb. I'm going to write it out. 1 standard deviation of the mean. So if we look at our mean is 40, we go 1 standard deviation below is 38. 1 standard deviation below is 42. So what range of chest measurements contains 68% of the 60% fall closest to the mean? We are going to say between 38 and 42 inches. That's the range that falls within 68% closest to the mean. All right, part B, what would you expect the chest measurements to be for the 2.5% of the men with the smallest chest measurements in the population? All right, so some things we can think about here. 2.5%, what do we know? We know 68% of the data are 1 standard deviation away. We know 95% of the data are 2 standard deviations away. So if we take the 100% of data, subtract 95%, that leaves us with 5% remaining for the rest of the data. And because this is a normal distribution, it's symmetrical on both sides. So if we cut that in half, 2.5% of the data above or below our 95% is going to get us what we need. So here's what we just looked at. 95% of the data, maybe I'll do a little highlighting, is all of this. 2 standard deviations from the mean. That's 95% of the data. All falls right here. So the remaining data is 5%. So 5% are below 36 and above 44. We want 2.5% of men with the smallest chest measurements. So if we cut that 5% in half, this is 2.5% and this is 2.5%. So we want the lowest. So we want that lower. We can say that 2.5% of the data will be less than 36. All right, part C. What would you expect to be the smallest and largest chest measurements of the middle 95% of the men? So 95%, that's one of our key percentages. If we look back at our normal distribution, we know that 68% of the data fall within 1 standard deviation, so from 38 to 42. 95% is the next one. 95% of the data fall within 2 standard deviations. So that's going to go from 36 to 44. So what is the smallest we can expect? 36 inches. And the largest we can expect to be within that middle 95% is 44 inches. Those are the measurements that are within 2 standard deviations of the mean on the upper and lower sides. All right, part D, what would you expect to be the measurements of the 16% of the men with the largest chests in the population? So there's many ways to go about finding this. How do we look at the kind of how we divide up our normal curve? So here's what we know. We know that here's the mean. Here's 1 standard deviation away. So what is this one? This would be 40. This would be 42. We know that half of the data, 50% of the data, is going to be above 40. We also know that 68% of the data is within 1 standard deviation of the mean, above and below. So if this is 68% of the data and this is symmetrical, we can cut that in half and say that this is 34%. From 40 to 42. Well, if we take 50, subtract 34, we get 16%. So that means that the rest of the data from here on out must be 16%. So what would you expect the measurements of the 16% of the men with the largest chest sizes in the population? We can expect them to be 42 inches or greater.